Hello there students. Okay, welcome to my channel. Okay, in this video I'm going to explain and elaborate about chemistry paper 4 May-June 2021, and this is a 42. Okay, so the time allocated here is 1 hour and 15 minutes. Okay, let us move to first question. Okay, number 1. The symbol of the elements of period 3 of the periodic table are shown below here. Okay, answer the following question about the state elements. Okay, each element may be used once, more than once, or not at all. Okay, write the symbol of an element. Okay, which is the first one is malleable. Okay, this is the characteristics of metal. So if you look at here, this is group 1, 2, 3, 4, 5, 6, 7 and 8. So the metal will be in a group 1, 2 and 13. So which is sodium, magnesium and aluminium. So all these answers is correct. So you can put either one of these. Okay, sodium, magnesium and aluminium. Okay, now has only 2 electrons in its outmost shell, which is the valence electron. Okay, so here will be under group 2. Okay, this is will be under group 2, which is magnesium. Okay, now C forms an oxide which leads to acid rain. Okay, the oxide, please remember the oxide for group 1, 2, okay, the oxide for group 1 and 2 will be more to alkaline. Alright, alkaline. So when we are moving toward the group 14, 15, 16 and 17, okay, this oxide over here is more acidic. Okay, it is more acidic. So if it's an acid rain, there will be only one element, which is the sulfur, because it will contribute to the production of a sulfuric acid. So the answer here is sulfur. Okay, now let us look at the D. Forms an ion with a -2 charge. So this one should be our in a group 16. Okay, in group 16. So which is also sulfur here. Okay, now is extracted from an ore called bauxite. So this is from aluminium oxide. So which is a group 3 here. Aluminium. Okay, does not form an oxide. Okay, does not form an oxide is the characteristics of argon, because it has a inert characteristics. Okay, this is a inert characteristic. It means it is stable and does not react to any of the particles. So here is argon. Okay, the next one forms an oxide with a macromolecular structure. So if you heard the word, if you look at here, the macromolecular structure, it should be silicon. Okay, and forms an amphoteric oxide. An amphoteric oxide, it can react with base and also acid. Okay, so they will have these two characteristics. So this one will be under group 13, which is aluminium. Okay, exists as a diatomic molecules. Okay, this one is under group 17. Okay, group 17. If you look at it, we have fluorine, chlorine, bromine, iodine. Okay, all this in a room temperature. Okay, in a room temperature, it will exist as diatomic molecules. So please remember this. This should be chlorine. Yeah, it's chlorine. Okay, now the last one, last question. Okay, forms a binary compound with a hydrogen that is a strong acid. This one must be chlorine because the combination of a hydrogen and chlorine, it forms a hydrochloric acid, which is a very strong acid. Okay, so this is the end of the first question. So now let us move on with the second question. Okay, number 2. Silver has an atomic number of 47. Atomic number is also the another word for proton number. Okay, so the P here is 47. A, naturally occurring atoms of silver. Okay, this one is 107 argentum, is quite small, and here is 109 argentum, and their proton number is the same, 47 and 47. State the name given to atoms of the same element with a different nuclear number. Okay, this is an isotope. So isotope, please remember, they have a same proton number, but different in a neutron and also nucleon. Okay, number 2, complete the table to show proton number, neutron and electron in each atom. Okay, this is an atom, and this one is an ion of silver. Okay, now the proton here will be 47. Proton must be same with electron for atom. Okay, is 47 and 47. And the neutron, you have to minus this. And you'll be getting here 60. Okay, if you look at here, this part, this one is an ion. And please remember, if they form ion, the proton number never change. They only changed at the electron part, because electron is the one being donated and also received. So here will be 46. Okay, and then if you look at here, this one is 109 minus with 47, you'll be getting the about 62, and this is your neutron number. Okay, we move on with the next one. Okay, number 3. Complete this definition of a relative atomic mass. Short form we call it as the RAM. Okay, relative atomic mass is the mass of naturally occurring atoms of an element on a scale where the atom has a mass exactly of this unit. Okay, so over here, this is the mean, or you can say average, of a naturally occurring atom. Please remember that in our periodic table, let me scroll. Okay, in our periodic table over here, all the elements is being compared, okay, in average with the element carbon. Okay, why they make the carbon as a reference point? Because it is abundant. It means it is everywhere. Okay, in food, in humans, in plants, even in minerals, they do have a carbon here. Okay, now let us go back to the question. Okay, this is the carbon atom. Alright, the carbon atom has a mass exactly of 12 units. They will be referring to carbon 12, which is the nucleon number. Okay, a sample of silver has a relative atomic mass of 108. Deduce the percentage of, okay, this is 107. Deduce the percentage of 107 argentum present in the sample of silver. Okay, let me give you another example of this, how to make this calculation. Okay, now let us make a we all know the chlorine, the RAM of chlorine is 35.5. So there is a two type of chlorine, which is a 35 and 37. But the percentage of 35 is about 75% or 0.75, and the percentage of 37 chlorine 37 is only 25% or 0.25. Okay, now how do we get this 35.5? So what we will do over here, we will take this ratio. Okay, we will take this ratio, we will multiply them. So this is the calculation, 35 0.7 multiply with 0.75 plus with 37 multiply with 0.25 divided with both of these add together, and you'll be getting here 1 and you'll be getting here 35.5. Okay, so this is the average. This is the average. So now we go back to the question, and they mentioned that it is 108, exactly 108, where we do have two types of argentum. One is 107 and another one is 109. So if it appears exactly in the middle, so the ratio here will be 0.5 and 0.5. Okay, so which is about 50%. Okay, now for B, silver nitrate is a salt of silver. Silver nitrate is this, AgNO3, is a salt of silver made by reacting silver oxide with an acid. Silver oxide with an acid. So what is the formula of an acid? So to get the nitrate, you have to react with nitric acid. So this is the formula of the acid. Alright, okay, now let us move on with the next one. Okay, C, aqueous silver nitrate is a colorless solution containing argentum ion. Okay, number 1, describe what is seen when an aqueous silver nitrate is added to a aqueous sodium iodide. Okay, this experiment is to determine the anion. Okay, let me elaborate here further. If there is a solution of unknown that could contain chlorine, bromine and also iodine, okay, so first we need to add this solution into nitric acid. Okay, first is with the acid, then we add on silver nitrate, okay. If there is chlorine exists, it will give out the color of a white precipitate. If there is a bromine, it will give out cream precipitate, like a milky color. If there is a iodine exists in this solution, it will give out yellow. Okay, this is for the anion test. Anion test for chlorine, bromine and iodine. Okay, this is a precipitate. All this is for the precipitate. So if you follow the question, they are asking for iodine. So iodine is definitely is a yellow color. So you can write there yellow precipitate. Okay, now write an ionic equation for the reaction between aqueous silver nitrate and aqueous sodium iodide. Include state symbols. They just want the ionic equation. Okay, so let me write it down the equation here properly. Silver nitrate and aqueous sodium iodide. Okay, so we just have to take the ion from the argentum and also the iodide. So argentum we have a positive, plus with iodine ion we have a negative, and it will form argentum iodide. Okay, this is the precipitate. Okay, this is the precipitate and this is a solid, because we need to put the state symbol. Okay, so both of these will appear as an aqueous. Okay, so this is your equation. Okay, now let us move to the next one. Okay, in positive tests for aqueous nitric ions, aqueous sodium hydroxide and one other substance are warmed with the nitric ions. Name this other substance and the gas form. If there are nitrate ion, okay, if there is a nitrate ion here, definitely here will be a ammonia. Okay, over here, if you look at the question, it is the positive test. It means it's a cation. So there is only one metal that can change the nitrate ion into ammonium ion, which end up giving ammonia gas. So this is aluminium. Okay, so we go to the next one, E. When silver nitrate is exposed to sunlight, silver is formed. Okay, this one is a photochemical. Okay, name the type of reaction. Yes, this is a photochemical. Photochemical reaction. Okay, members of one homologous series only react with chlorine in the presence of sunlight. Okay, the process is called as a substitution process. Substitution. It will only happen in alkane homologous series. Name a member. So name a member. You can name it methane or ethane or butane. Okay, anything that, but it must be under alkane. Okay, name two products that form when compound in 1 react with chlorine. Okay, let me give you an example here. Let's say we choose methane with the chlorine. Okay, so we have here 4 bondings of carbon because it has a 4 lateral valence, and this is a chlorine. Okay, under the influence of the UV light, what happens is this chlorine will replace the hydrogen here, and it will become and here you'll have chlorine. Okay, while it is at free, while the hydrogen is free, this hydrogen will go and combine the chlorine over here, end up producing hydrogen halide. Okay, so these are the two products. Now we go back to the question. So name two products. So you can say it is hydrogen chloride, and here you can say it's chloromethane. There is another name for it. You can also say as a methyl chloride. Okay, Okay, now for question number 3. Sodium hydrogen carbonate is found in a baking powder. When sodium hydrogen carbonate is heated, it forms 3 products. Okay, this is the equation. Okay, first one, A, name the type of reaction that takes place when sodium hydrogen carbonate react in this way. When you have an equation, something in this form, this one, and then they are heated to form at least 2 substance or more. Like example for this one, and it is heated. Okay, so your only answer here is a thermal decomposition. Okay, for B, calculate the volume of carbon dioxide formed at the room temperature and pressure. This is in short is RTP when 12.6 gram of sodium hydrogen carbonate is heated using the following step. Okay, we have to use this equation. So what I'm going to do here, I'm going to erase this and I'm going to, I think better if I write it over here. Okay, now we have to follow the number in front. So here's a 2, here's 1, so everything else is 1. Okay, this is the main ratio we are going to find. Okay, now 12.6 gram of sodium hydrogen carbonate. So 12.6 mass to mole we have to divide with R/mm. Okay, so sodium is given by 23, hydrogen is 1, carbon is 12, and oxygen is 16. So the addition here will be 23 plus with 1 plus with 12 carbon, and here oxygen we have 3, so which will be giving us about total of 48. So here when we calculate this, we will be getting 12.6 divided by, okay, let me calculate this. We'll be getting around 84. So the answer here you'll be getting is 0.15. So here you'll be getting 0.15 mole. Okay, so we have to use the ratio of 2 is equals to 0.15. So if there is 1, so everything here will be equals to 0.075. Okay, this is all is a 0.075. Now they are asking for the RTP volume of carbon dioxide. So we just have to take this, the mole, and multiply it with a 24 d metric cube, and we will be getting our answer here. .8 d metric cube. Okay, now let us answer the question one by one. When they are asking the mass, it is a RMM, which is 84. Okay. Okay, now second one, calculate the number of moles, and we have calculated this and we are getting here 0.15 mole. That's your answer. and determine the number of moles of carbon dioxide. So remember to use the ratio. If 2 is equals to 0.15, 1, everything here will be equals to 0.075 mole. So that is your answer here. And using the mole, and we can answer the volume. So 0.075 multiply with 24, which will give you 1.8 d metric cube. So this is about total 4 marks there. Okay, now the next one. Okay, lime water is aqueous calcium hydroxide. Calcium hydroxide. Carbon dioxide turns lime water milky because of a white precipitation form. Write the formula. Okay, I write this. The white precipitate that forms when lime water turns milky. So it will change to calcium carbonate. Okay, calcium carbonate. So remember, carbonate, all carbonate is insoluble and will form precipitate. Okay, now let us continue with the fourth question. Okay, number 4. A student carry out an electrolysis experiment using the apparatus shown. Okay, this is a carbon electrode and electrolyte. This is an electrolyte. Okay, they are using sodium chloride, aqueous sodium chloride. So the ion here, we have sodium, chlorine, and for if you have aqueous, it means it contains water. So water has a hydrogen and hydroxide. Okay, now let us go to the question. Okay, the student uses a dilute aqueous sodium chloride. Okay, state the name given to any solution that undergoes electrolysis. So which means they are asking for the name of this solution. So it is given electrolyte. That is your answer. Okay, now what are the next question? Okay, hydroxide ion are discharged at the anode. Okay, when they are discharged, complete the ionic half equation for this reaction. Okay, remember, when you have a hydrogen ion being discharged, it must release water and oxygen. So when you balance this, you'll be getting here 4. Remember, here must be 4 and here must be 4. Okay, so when you balance the molecules, here you must have 2. So there will be a 2 hydrogen and 2 hydrogen this side and 4 oxygen, 2 plus with a 2. Okay, explain how the ionic half equation shows hydrogen ion are being oxidized. You can simply say because it releases electron. Okay, it releases electron. Or you can also say in more accurate word, it loses electron. Okay, now let me just explain further details of here. Okay, now here we will have cathode. Okay, so here is positive and here is negative. So this positive ion will be attracted to the negative. So if you look at this electrochemical series, the bottom of the series will be hydrogen. So here you have a hydrogen taking the electrons and form hydrogen atom. So this hydrogen atom cannot appear as monoatom. So they will combine and form hydrogen gas over here. At this side, you will have hydroxide. So we follow the equation, you will be getting this. And here you will be releasing oxygen gas. Okay, now let us look at the further details of the question. Describe what the student observed at the cathode. Okay, so if you notice that at both sides you will have gas release, okay, hydrogen and also oxygen. So over here you can write the bubbles, okay, bubbles observed, or you can write the fizzing. Okay, write the ionic half equation for the reaction at the cathode. So I'm going to rewrite what I've explained over here. Okay, so this is your half equation. Okay, the student repeat the experiment using a concentrated aqueous sodium chloride. Okay, once you have the word concentrated, it will be affecting the anode side. Okay, let me explain to you in further details at the end of this page. Okay, now at cathode, and here we have anode. Okay, if it is a concentrated, so please remember you will have about 80% of the substance and 20% is the water. Unlike aqueous solution, so you have the 50% of the substance and the 50% of the water. So the chances are more higher to water. So now for cathode, we have sodium and hydrogen. Anode, we have chlorine and we have hydroxide. Okay, now when you're talking about concentrated case, all right, so it only affects the anode side, so which is here, this part. And remember, 80% the solution contains chlorine, chloride ion, but however another 20% is hydroxide. So since the percentage of hydroxide is lesser, so the chances of chloride ion to get discharged is much more higher. So at anode, you will have chlorine gas. It is a halogen, so it will appear as a dewy atom. At cathode, as usual, you will have a hydrogen. So this is the scenario for the concentrated solutions. Okay, so at anode it will release chlorine gas, at the cathode it will release a hydrogen gas. Now we look back at the question. So at cathode you will have is hydrogen, and at the anode here is a chlorine. They are asking what the student observed, so you just can say it's fizzing because we cannot see the hydrogen. Okay, but anode it has a green color, so we can observe the color, so we can say that there is a green color gas coming out. All right. Okay, now for number 2, the student added litmus to the solution after electrolysis of the concentrated aqueous sodium chloride. State the color seen in the solution. Give a reason of your answer. Okay, he added litmus paper into the solution. Okay, now what happened over here? Let me go back to the story. Okay, now, so eventually what happens is the percentage of chlorine will be lesser and the percentage of hydrogen will be lesser. So what is remaining in the solution? We will have a sodium and hydroxide. So sodium and hydroxide, they'll combine to form sodium hydroxide. So this is definitely is a alkaline solution. So it will be changing red color litmus paper to blue. Okay, so now let us go back to the question. Okay, color of the solution. It changes red to blue. Reason because formed is alkali solution. Okay, carbon electrode are used because they are inert. State another element that can be used instead of carbon. So in the beginning of the chapter, they got mentioned as a two elements there. One is a carbon, another one is a platinum. In industry, they will use carbon most and less platinum because platinum is quite expensive compared to carbon. Okay, so this is for question number 4. Here, so total mark is 12. Now let us go back and we go through question number 5 now. Okay, question number 5. This question is about compounds of nitrogen. Nitrogen reacts with lithium to form lithium nitrate. Okay, write a chemical equation for the reaction between lithium and nitrogen. Okay, lithium appeared as 1, is a metal, and nitrogen is will appear as a gas. So here we will have 3 and N. So we have to balance this. So here will be, if we put 2 here, lithium will become 6 and nitrogen will be 1 over here. Okay, that's all for our 2 marks. Okay, now let us go to lithium nitrate is ionically bonded. Yeah, because it is a metal here and non-metal over here. Okay, complete the diagram to show electronic structure of this nitrate ion. So nitrate, basically you will have 7 electrons. So if you look at the periodic table, you have 14, 7 nitrogen. Okay, so the electron arrangement here will be 2.5. It is a group 15 and you have a 2 period. So when it form ion, they will receive 3 electrons to be stable. So here is how we get nitrogen ion 3 negative. So here will be 3 negative and we have to add on one more shell over here. Let me draw it more beautiful. Nope. Okay, I think this is okay. Now we have to add in 1, 2, 3, 4 and 5. This is the original. Okay, and they will add on, it will become 2.8. So we can add on, here is the borrowed, not borrowed, it means it's donated. Okay, you have that 3 electrons. Okay, 1, 2, 3. Okay, so this is the 2 marks. Now we move. We'll continue with the questions. Okay, for B, nitrogen reacts with fluorine to form nitrogen trifluoride. The chemical reaction can be represented as shown as this. Bond energies are shown. Okay. Now let me explain to you over here. First, they have to break all these bonds. So to break the bond, you need to absorb heat. If you absorb heat, it is called as endo. Okay. So first we need to take nitrogen, triple bonding 1. So we have here 9, 4, 5. And we have to take fluorine, which is 1,6,0, and here we have 3 molecules, and we add on all, you will be getting here 1,425. This is a kilojoule. Okay. So now over here they need to form the bond. When you need to form the bond, what happens is you will release the heat. So releasing the heat, you end up as the exothermic. So here we have N, F. Okay. So we have here 1, 2, 3. Multiply with 2. So total we have about 6 bondings. So 300 for 1 multiply with 6. So here we have about 1800 kilojoule. Okay, now the energy taken in to break the bond is this. Okay, this is number 1. So 1425 kilojoule. The next one here will be energy released when bonds are formed, which is number 2. Okay, so it's about 1800 kilojoule. Now the energy change during a reaction. So 1425, so we just assume it's a positive and this is a negative energy. So minus with 1800, so we'll be getting here about negative 375 kilojoule. Okay, so this is exothermic because it is a releasing heat. So you can say the reason is more energy released when forming the bond. Compared to energy used in breaking bonds. Okay, so this is 1 mark. You can make the answer much more shorter. Okay, now complete the dot and cross diagram to show the electron arrangement in a molecule of nitrogen trifluoride. Okay, use dot for nitrogen electron and cross for fluorine electrons. Okay, outer electrons only. Okay, so my advice here is please train the drawing with the Levy structure. Okay, Levy structure. So and here nitrogen you have 2, 5. So this is a valence electron. So 1, the answer is to use dot for nitrogen. Okay, dot 1, 2 and 3. Okay, so here is the balance which is not reacting. Okay, if you look at fluorine, it has about 9 electrons, which is 2.7. So at the outer electrons you have only 7. So fluorine, you have only 1 over here, and the rest you can draw it at the side. So make sure you have 7 in total. Okay, so this is, we call it as a Lewis structure, and you can see the sharing part, the bonding over here. Okay, this must exist exactly in here, over here. All right, so let me show you. Okay, now we just follow the dots inside 1, and here's 2 for nitrogen, and for fluorine here we have a cross 1. We need to draw the others at the side. So we have another 2 more. Okay, so this is how to draw. All right, so this is about 3 marks over here. Okay, now let us go to the next question. Okay, lithium nitrate melts at this because it's an ionic bonding. Nitrogen trifluoride melts at the negative 206. Okay, this is a covalent bonding. Okay, explain in terms of attractive force why lithium nitrate is much more higher melting point compared to nitrogen trifluoride. Refer to the type of attractive force between particles and their relative strength. Okay guys, this is my suggested answer, and sorry for my bad handwriting. So you can see that lithium nitrate, which is ionic, okay, has a strong ionic bonding which requires high heat energy. I have to add in here heat energy to break their bonding. However, okay, wait, there's a small mistake here. Okay, however, we can write there nitrogen trifluoride okay, has a very weak covalent bonding between the molecules and require little energy to break their bondings. Okay, so you just have to relate what bondings they are and how strong they are, okay, to get your 3 marks. Okay, now let us move to the next question. Okay, ammonium nitrate is a compound of nitrogen. Calculate the percentage by mass of nitrogen in ammonium nitrate. Okay, in this case we have to calculate the total RMM. So let me list down over here. Nitrogen is 14, hydrogen is 1, and oxygen is 16. Okay, now we have here 2 nitrogen, right? Okay, 2 nitrogen, so 2 times 14 plus with you have there about 4 hydrogen plus with 16 times with 3, and you'll be getting all together about 80. And if you look at nitrogen, you only have about 2, so which is about 28. So to calculate the percentage, you just have to calculate 28 divided by 80 multiply with 100, which gives you about 35%. Okay. State the use of ammonium nitrate in agriculture. You can say it is used as a fertilizer. Okay, state a name of a compound that will displace ammonia from ammonium nitrate. You can say it is a calcium hydroxide. Okay. Okay, for ammonia is a base which forms weakly alkaline solution when dissolved in water. Okay, base is a proton acceptor. And if they are asking the acid, same question, define the terms of acid and remember to write here proton donor. This is a frequent question from IGCSE. Okay, suggest pH of aqueous ammonia. They already mentioned here is weakly, right? So you can write there more than 7 and less than, you can say 10. Okay, this is quite weak. So the total mark for question number 5 here is 20. Okay, now we are going to the last question. Okay, for number 6, molecule A and B can form a condensation polymer. Condensation polymer is a polymer where they combine, okay, they combine and they will remove a small molecule, example like water. Okay, this is the meaning of a condensation polymer. Okay, now A is alcohol. A is an alcohol group and the B is a carboxylic acid group. Okay, each molecule has two identical functional groups. Name functional group at B. Functional group is this. Okay, now they are asking, draw the part of structure of synthetic polymer that would form when two molecules of A and two molecules of B combine. Show all bonds in the linkage. Okay, so what happened over here is when the OH group and the acid group combining, right? So what happens is this OH and the OH here and the H over here will combine to form water. Okay, they'll combine to form water, leaving only COO. Okay, let me explain to you in more detail. So when we have here OH, okay, OH, and here we will be having C, carbon, double bond with oxygen, and we have O and H. So this is, let's say, it's A, and let me just put a color here, and this is a green color. So what happened here is green and the blue. Okay, so leaving behind only this part. Okay, so here you have carbon, double bond, oxygen and oxygen. That's all. So the OH from alcohol group and the hydrogen from the acid group will combine to form water. Alright, so this is the basic part. So we are going to use this to solve the question. So here we have 2 molecules of A and 2 molecules of B. Okay, so in between we will have the B, remember, is a acid. So we have here C double bond O, and here we have a O. Okay, so we just have to draw it for all of this, and this one is and here's carboxylic. Okay, so A is as alcohol, so at the end here we can put oxygen and hydrogen. At the B side here we have to put acid. Okay, so here will be hydrogen. Okay, so this is the drawing part. Okay, now if you look at the next question here, name the other products formed when molecule A and B undergo polymerization. So it's water here. Okay, molecule A is a simple sugar unit which can be made by hydrolysis of a complex carbohydrate. Now, draw part of complex carbohydrate that could be hydrolyzed to make a molecule A. Okay, let me explain to you in further detail about this. Okay, now let's say we have a simple molecule. Okay, A plus with A, and you'll be getting a B. Okay, so this is a simple sugar and this is a complex. So when A plus with A, and here you will undergo condensation process which will release water. So if you want to go back from complex to simple, we have to do a hydrolysis over here, which is adding the water to the complex part, so that you will be getting the simple sugar. Okay, now let us look back at the question. Okay, let me explain to you in detail over here. Molecule A is we have here OH. Okay, we have here O and H. So you will have another OH over here. Okay, when they combine, so this is a two simple sugar. Okay, let's say we just put that an A and A. How do we form a complex carbohydrate? So we have to remove the water, am I right? So these are the water. So you'll be getting two, you have here only the oxygen and you release the water. So here you have OH and here you have O and H. Okay, so draw the part of complex carbohydrate that could be hydrolyzed to make molecule A. So it means like they are asking us to go reverse. So this is the part where we need to add in water. So your answer should be this. Okay, your answer should be this one. You have to draw this diagram. Okay, now for number 2, state two set of conditions which could be used to hydrolyze the complex carbohydrate to form A. Okay, one is by using enzyme. Another one, you have to use acid. okay, acid, and then you need to heat it up. Okay, now name the technique used to identify the individual sugar unit made by the hydrolysis of a complex carbohydrate. So you can say the technique is a chromatography, because anything to do with food molecules, so we need to go through the chromatography. Okay, ethanol can be made from a simple sugar, glucose. So ethanol you can make it in two ways. One is fermentation, another one is hydration of alkene. Okay, now here we have ethanol plus weight. So here you'll be having a carbon dioxide plus weight. Okay, only carbon dioxide. So when we balance this, here you'll be getting 2 here and 2. Yeah, so you'll be getting here 1 mark and 1 mark. So the total mark for this question is 12 marks. Okay guys, so this is set 42, May-June 2021. So if you have any questions, please comment below. I will reply to you very soon. Okay, so thank you very much and all the best for your coming exam.